Hello and welcome to this Godot movement tutorial being recorded for DurJam 2025. My name's Ryley. I've been the lead organizer this year, and I've also been producing all of these workshops. So all of the workshop recordings that you've been seeing, I've been behind the camera. Today I'm in front of the camera to talk to you about Godot movement. So we're going to go through 2D and 3D movement in Godot. I've got a demo game that you can go play that's on itch that showcases the 2D and 3D movement that you're able to achieve in Godot as a starting point for your projects. So the itch link will be in the description along with the GitHub link with the full tutorial and all of the files I'll be using here. I'm here to talk about basically how to start your scene, how to get your character moving around, and then where you can go from there. Well, first of all, what is Godot and why do you want to be using it? Well, it's an open source game engine, which is really good for newcomers, I think, and so a great place to start when it comes to game development. I did my first game development in Godot and I found it a really easy to learn experience. The programming language they use is GDScript. So the GDScript that we'll be using here is Pythonic, but it's in a C# object-oriented format. So that Python that lots of people already know and understand is sort of developed through learning game development through GDScript, which I think is really useful. So the first thing we're going to want to do is download the Godot engine itself. The latest version is on the website, godotengine.org. My latest version at time of recording was 4.4.1. You might have a slightly newer one, but don't worry, everything we'll be learning here is probably going to be applicable to whatever version you're using. There's always the Godot docs, which if you want to use them, are very useful. Create your new project. So start a project, name it whatever you like. I usually suggest to create projects using the compatibility setting because it means it's the best for creating HTML exports for an itch.io page. I always use itch for my games, so I always like to have an export on there that people can play. The demo that you'll see later is an itch export, so I use compatibility mode for everything that I did in this tutorial. So I suggest that, but there are different settings if you want something else out of your end product game. When you start your new project, it will look a bit like this. It's a screen with HUD around the sides and a viewport in the center. No matter what type of game you're making, a 2D or a 3D game, your viewport will show the game as it is. And the thing that's important for us today is on the left. It's called the scene tree. So we'll be working with the scene tree to add new nodes to our scene. Godot works using nodes, so your nodes are essentially your characters, your enemies, your backgrounds. Different components, different objects in your game are created using nodes. So we'll be doing that today. First thing I'm going to want you to do is add a new scene and name that character. Our current scene is called scene, so that's the basic scene. The character being in its own scene means that whatever happens with the character stays within that character scene, and we can then import that into different new scenes. So if you had a different background, for example, you can still put the same character in that background. So your scene got started with a node2D object. That's just a basic node that says that the scene is 2D. Our next node here is going to be a character body 2D. So that's what our character is actually going to be using to collide with things and to act. Our script's going to be attached to that character body 2D, so that's the important part. That character body 2D actually has other nodes underneath it, so there's nodes being a collision shape. The collision shape tells the character body 2D what parts of it will collide with other objects. So for example, in the floor, in a platformer game, or the wall, or the side of the screen, things that the character can't walk through and will collide with. That's what the collision shape is actually defining. The last thing that we're adding to this scene is a sprite 2D. So that's the actual image that the character is made up of. If you want, that could end up being an animation. So that would be the art behind your character. So the art behind your character and the collision shape are two different objects, but they'll often be a similar shape. Here I'm using just the Godot icon that comes with the Godot engine, but you can use whatever you like. The next thing we're going to need to do is set up for the code itself. We need to tell Godot which buttons we're using for our actions. So we're going to go to Project Settings and then Input Map, which is the second tab, and we're going to add the following actions. We're going to add left, right, up, and down. So we're going to be able to tell it which buttons we're going to be pressing to do those actions. So within our code, we'll be able to use the phrases left, right, up, and down instead of saying user presses this button, for example. So I'm going to use WASD. You could also use the arrow keys for your 2D game. Both are convention, or you could use whatever buttons you like, depending on what your game is going to be. Now that we've done all the setup, we can attach a script to the character body 2D node. That's where our programming will actually be. Now all the code I'm about to talk to you about will be in the GitHub link below, so it's 2d-movement.gd, the GD script file, but we'll talk it through here right now. You can either have your movement be top-down style movement, so up, down, left, and right will literally be up, down, left, and right, or you can do a platformer style movement with the effect of gravity, so that will mean that you go left, right, and your up is a jump action and your down could be something like a crouch action. So the keys are the same, but they are drastically different depending on how you want to do them. Firstly, we'll go through up, down, left and right for a top-down view because that's a little bit easier. You're using the same method for left and right as you are for up and down. Gravity will be a different physics process that we'll work through. Essentially going through the code, we've got a variable for speed, so that will determine how fast our character's moving, and then we'll get the input from the user. So every single frame, we'll be seeing if the user has inputted the left, right, up or down keys, and if they have, we're getting those as a vector. So the velocity with the input direction of the x-axis, so if you're going left, that's negative x, and if you're going right, that's positive x, that will be taken into account, and also the velocity in the y direction will be taken into account depending on the y direction of the velocity, so up being positive y, down being negative y. And then in our physics process with delta, so every frame, we're going to be getting that input and moving and sliding, so the velocity will be used there. This is very, very simple and gives you great 8-directional movement, which can be used in top-down games and is a brilliant start just to get you going with a project. Now you just add some art in there and it will look great. But what if you want to make a platformer style game? So let's say we want gravity, we want to jump onto things. That'll be a little bit more complex. We need to add gravity into our code. So instead of using velocity of y, so instead of going up and down with the y, we want to be jumping with up. So we want up to mean jump. So we want to check if the up or the jump action has been pressed. We also want to check if the character is on the floor, so if they can jump. This is an inbuilt GD script function, so this is brilliant for this. And if it is, we're going to give it velocity based on our jump velocities. That's a different variable that we're going to be using here. Another variable we're going to use is how much gravity there is in the environment. So that's going to be another thing that we take into account. In the physics process, we're actually going to be doing that handling of gravity. So if the character isn't on the floor, we want it to be going down. So if not on floor, we're going to put downward force on the character. Now you've finished. Your platformer game is done, and your character can move up and down and jump on objects. You might want a few objects in there, so you might want to make some static body 2Ds for your character to jump on, just so that you know that your environment is usable. Now you have top-down or platformer movement in your game, you can add little twists to it. So you might want to do a roll, or a dodge, or a crouch. You can add those new actions to the input map and add code to your character body 2D script, and that will be great for pushing your game a little bit further, adding a few more game mechanics, that sort of thing. But this is a really good starting point for a project, and means you can create what you want to be creating quicker. When your game is there, you've got a usable, playable game. And that's really why I love Godot, because that's really quick, and now you have a usable project. Even cooler is how quick we can do the 3D movement. Now we're going to be applying the same thing to a 3D project. So what I'm going to be doing is making a new 3D project, a new scene. Instead of a node 2D, we're going to make a node 3D in our scene. You want your first scene to be called scene, and then another scene to be called character, just as we did before. So this 3D character scene is a little bit different to the 2D character scene. We're going to want a few more things than we had previously, but we are still going to start with a character body. So character body 3D, and that's going to have some children. Those are going to be a mesh instance 3D, so that's going to be the physical mesh. It's a bit like our sprite 2D from last time. If you remember that, that's the physical thing that's there and it's visible and being rendered using the game engine. So we're going to be using a pill shape here because that's the convention for 3D shapes, but you can use whatever you like. If you've got a 3D model somewhere, that'd be great. Our collision body 3D is going to tell our character body 3D what it can walk through and what it needs to be able to stand on, the level it's standing on. So this is all pretty conventional and the same as the 2D character, but instead of just stopping there, because our view isn't just going to directly be from above, we want to have our view be from the character itself, we're going to need a camera. So our camera is going to be a camera 3D, but it needs to be on a different node. So a node 3D we're going to call neck. So our neck node is going to be about here on the character with a camera coming out of it. That camera is going to mean that we have a field of view, a sort of first-person view on this character that's being rendered as the primary camera for the scene. Once you've done that, do the same thing as the 2D scene. We're going to be changing the input map so that we have all the buttons we need to move our character around. So left, right, forward and back is what I've called them here, and you're also going to want jump. Because when we have gravity, people like to be able to jump in order to do platformer style games. I'll be doing a platformer game later with this 3D scene, so that's what we're going to do here. Don't worry about the mouse movement, so we're not going to be using an input map for the mouse. We're going to be using a Godot mouse mode captured, in order to capture the movement of the mouse and use that for the perspective of the camera on the neck. So that will happen later with the code. Another thing that we'll need in this 3D scene is something for the character to be on, or else it'll be continuously falling into the void. So we're going to be doing a mesh instance 3D, and that mesh instance is going to be a surface mesh. This is just a surface, so you can just see the floor. And this surface mesh needs a cubic static body 3D, which is going to have a cubic collision shape 3D. So these are going to be the floor that the character is actually going to be sitting on, and you'll be jumping off of using gravity. So this is a mesh instance 3D with the children static body 3D and collision shape 3D. You'll also need to add a light into your scene. I've used a directional light here that's quite strong and facing down because I just want to light the whole scene quite quickly, but you might want to use something like a world environment where you can use a skybox as well. Those are quite good. Just to make sure your scene looks cohesive and also so that you can see it on that perspective view on your camera 3D on your character. Now on to the cool part, we're going to be attaching our script to Character Body 3D so you can actually program your character. Again, the code is in 3d-movement.gd, the GD script file in the GitHub link, so that's down in the description. You're going to want to use that there. But I'm going to run through the code here for you now. So this code is a little bit more detailed. We've got the speed, we've got jump velocity for how fast we're going to be jumping, but we also have gravity. This is going to be a preloaded Godot gravity. So we're using the default gravity physics settings in Godot. You can, I think, import different gravity settings if you want to go that deep into it, but we're just creating our basic scene as quickly as we can here, so we'll be using that. We need to preload our neck and our camera nodes so that we can use them later on in the code, so those will be like variables up at the top as well. Our physics process has some similar things from last time, so we're going to be saying if the character's not on the floor, it's going to be feeling the effects of gravity, so it's going to be going down. And if the jump action is being pressed, then it's going to be going up using our jump velocity variable. We're then going to take the input direction based on left, right, forward, and backward. And we're going to transform that vector based on where the neck is pointing. So if you're going forwards but looking this way, you'll be going that direction. Forwards but looking this way, you're going in that direction. So that's why that's important. If the direction changes, we want to change our variable for movement, but if it's not changing, we're going to move towards that direction. We're still using move and slide. The more interesting and more detailed thing here is our mouse capture. So this is for our perspective movement when you're moving the mouse to see in different directions. This is using an unhandled input. Is if you click the screen, we're going to start capturing the mouse movement. When you move your mouse, we're then going to change the perspective of the camera. And if you press the cancel or escape button, we're going to stop capturing that mouse movement for the perspective movement. So this is some really basic 3D movement, which I think is really cool, because now you can put different things like 3D objects into your scene that you can walk around and look at, or you can make an art gallery, for example. I feel like this sort of very basic scene is a great starting point for someone wanting to focus on the art of their game, because you can make lots of different art here now that can really uplift the game from this basic concept and allow people to move around a space that you've created yourself. So now I'd like to showcase this movement demo game. So this movement game is based very much so on the 3D and 2D movement tutorials that I've just showed you. You can move around the space in 3D. The blocks are blue that you're stepping on, those are your platforms, and when you've traversed that platform, it turns red. So this is reflected in the 2D game you can also play if you press E. You switch to the 2D game, you're jumping around on blocks. The only difference is if you press a block again, so if you step on a block that you've already stepped on, it turns blue again, so it becomes unvisited. So your goal is to visit all of the squares an odd number of times. I think this is quite a fun twist. The theme for DurJam 2025 was twist on a classic, and I've twisted the classic platformer so that instead of trying to get to a specific location, you're trying to visit as many as you can. So we're going to try and visit every single platform to turn it red, which I think showcases a lot of this movement quite well. You can even use the twist from the 2D game. If you press on a block or step on a platform twice, then it changes back to unvisited in the 3D game by pressing Q. That's a little secret, and you can try a cool version of that game there. That's an alternate version of the game. Feel free to check out this tutorial. The project is all in the GitHub, but you can also check out a playable version, the HTML playable version on itch, so you can go play it there. And that's a very cool way to interact with this tutorial, so I very much recommend that. Well, thank you very much for watching this tutorial. Please check out the GitHub link for all of the code that you'll need to use to get started with your Godot project. I wish you best of luck. Making games in Godot I think is really, really fun, and getting a starting point that you can jump off of is always the best. I would suggest looking into more tutorials, so tutorials about texturing your scene, about adding different types of lighting to your scene. Those would all be really useful to make and uplift your project into something that you'd want to play, because that's the key with game development, is to make stuff that you think is fun. And enjoy making your games with Godot.